Chapter 8, Part 3, Reactions of Alcohols, Part B. This part just focuses on the oxidation of alcohols. So before we get started actually looking at the reactions, it's important to note that it's going to look like we're learning a lot of different things, but we're really not. There are mild oxidants and strong oxidants, and depending on the substitution of the alcohol you're reacting with, there's only one possible outcome in each of these combinations. So when a primary alcohol is reacted with a mild oxidant, it will always make an aldehyde. A primary alcohol reacted with a strong oxidant will always make a carboxylic acid. A secondary alcohol, no matter the strength of the oxidant, will always make a ketone. Very simple. A tertiary alcohol cannot actually be oxidized, and there will be no reaction. Now, an aldehyde is not an alcohol, but it is a step towards the oxidation, and so I included it here because you will see stuff like this as well. An aldehyde cannot be further oxidized with a mild oxidant, but if you do take an aldehyde and react with a strong oxidant, you'll be basically picking up here, so you go to a carboxylic acid. So keeping this in mind, let's take a look at our different oxidants. So there is one oxidant that we will classify as mild, and this one is called PCC. PCC is shorthand for pyridinium chlorochromate. Pyridinium chlorochromate is formed in situ, meaning in the reaction, by mixing pyridine, hydrochloric acid, and chromium trioxide. So when these three reagents are combined, you end up creating an ionic compound. You protonate the pyridine by picking up this proton. That frees up the chloride to react with the chromium, which previously would have had 3 double bonds to the oxygens, and creates this anion. So we have an ionic compound as our reagent here. Now, when PCC is reacted with the primary alcohol, DMSO is our solvent here, it's not another reagent, we end up making an aldehyde. And that aldehyde is going to form on the carbon that was previously the alcohol. So we draw the same structure we already had. Here is our carbon that had the alcohol. Now, instead of reproducing our alcohol here, we are going to draw an aldehyde. So you can kind of see why knowing the names of your functional groups and their structures is going to be really, really important as we move forward, because we are talking about these transformations in terms of I start with this functional group, I react with this type of reagent, and I end with this functional group. On the next page, we have our 3 strong oxidants: potassium permanganate, chromic acid, and Jones reagent. Potassium permanganate may be paired with hydroxide, water, and or heat. So you might see any kind of combination of this, or you might just see potassium permanganate. Now we're going to react with a primary alcohol again. So anytime you see one of these oxidation reactions, always ask yourself, what is the classification of my alcohol? This one's primary. And according to our chart, a primary alcohol, when reacted with a strong oxidant, is going to make a carboxylic acid. So this is the carbon that this reaction is going to occur on, and I'm going to draw a carboxylic acid on here. Looking at the next one, this alcohol is a secondary alcohol. So any oxidant that I were to react with would turn it into a ketone. This happens to be chromic acid, which is a strong oxidant. So I'm going to draw my carbon framework again, locate my carbon that was previously the alcohol, and I'm going to turn this into a ketone. On the next one, I did another secondary alcohol because tertiary alcohols do not react. And this is Jones reagent. Jones reagent may be written out as a reagent, just saying Jones reagent, or it may be written out as its parts. Jones reagent is formed from chromium trioxide, sulfuric acid, and water. So I'm going to draw my same carbon framework. identify the carbon that was previously my alcohol. And since this is a secondary alcohol, I know this is going to turn into a ketone. And that's how you do oxidation of alcohols.